Chapter 10, Lesson 3, Solve Quadratic Equations by Graphing. So, just like previously we solved systems of equations where the two lines crossed and figured out which point they crossed at, this is sort of similar. What we're looking at is we're looking for the point at which the parabola crosses the x-axis. So here, the x-axis right there. Because the thing about it is that x-axis there, that is where the two solutions are going to be. So what I want you to think about is this, that this is an example of how it was graphed, how graphing can use for this. So if you look here, x squared plus 5x is equal to 14. You're going to change that to writing it in standard form. Then we're going to graph that. The way I like to do it is I like to find that bottom point first. So I'm going to go ahead and I'm going to change, remember that negative b, so in this case here negative b is going to be negative 5 over 2a, so it's going to be 2 times 1. So it's going to be negative 5 over 2, so it's going to be negative 2 1/2. That's going to be that trough point. That's going to be the line of reflection where that point is right there. So now I'm going to if I plug that in and figure out what the point is, that's fine. But I now have my line of where the symmetry is, and now I can just go ahead and figure out based on that. I'm now going to just solve this using the roots, where I'm just going to go ahead and go x squared plus 5x minus 14. If that's equal to y, all I'm doing is I'm solving for roots when y is actually going to be equal to 0. So sort of what we've done before. So now it's just going to be x, and hopefully this makes sense, x plus 7 and x minus 2. That's going to be equal to 0. That's going to be where it crosses the y-axis. And so my points are going to be negative, or my two roots are going to be negative 7 and positive 2. And if you look there, that makes sense because that's positive 2. That there is negative 7, positive 2. And so those are the two roots, and those are the solutions for the quadratic equation. So that's what we're going to be looking for. For this one here, we're going to set up the equation the right way. X squared minus 10x plus 25, and that's going to be equal to 0. So again, we're going to rewrite this, x squared minus 10x plus 25. And now I'm going to figure out that line of symmetry. It's going to be negative b, so that's going to be 10 because it's negative negative, over 2 times 1, so that's going to be 5. So that's going to be my line of symmetry. 1, 2, 3, 4, 5. So approximately right there. It's my line of symmetry. So now I have to do is I now have to figure out what the actual solution is when y is equal to 0. So let's do that. 0 is equal to x squared minus 10x plus 25. And so it's going to be x minus 5 squared. So it's actually going to be, the solution is x is going to be equal to 5. There's only one solution because it's squared. So the only part where it goes ahead and crosses, it doesn't really cross, it just hits right there at the 5. So that's the solution. There's only one solution in that case. And this is a special case because it's a perfect square one. So now let's look here. Different case here. X squared minus 5x plus 11 is equal to 0. Well, we'll come back to that in a second. So it's going to be x squared minus 5x plus 11 is equal to y. That's the first thing we want to do. So let's figure out where that crossing point is, or where that line of symmetry is. It's going to be negative b, so that's 5 over 2a, so 2 times 1. So my line of symmetry is going to be 5 halves. 5 halves is going to be right about here. So that's 2.5. So now let's solve this part here. And this one here is harder to do because we can't actually come up with a value here. But let's plug this into there and let's see what our first point is going to be. And then we can go from there. So if we plug this into there, what we're going to end up with is we're going to end up with, actually if we plug this into the original equation to see where our y coordinate is for that trough, then we're going to go from there. So now let's see, 5 halves squared minus 5 times 5 halves plus 11. That's going to be, well, 25 fourths minus 25 halves plus 11. Let's change that all into fourths, so we end up with 25 fourths minus 50 fourths plus 44 fourths. Okay, so this here, it's going to give me, this part here gives me negative 25 fourths, and then I'm going to end up with 19 fourths here, which is going to give me actually 4 3/4. So very importantly, that first point, if I go up 1, 2, 3, 4, 1, 2, 3, 4, that first point is going to be right there. And then you got to pay attention here. What's the value in front of A? It's a 1, even though we can't see it. So this parabola is going to go up like that. So this has actually has no solution because it does not cross this x-axis there. So that's an important thing to note in order to make sure that you actually have the right solution. So let's try this one here. This one's a little bit easier. X squared minus 2x minus 15. And so that's going to be equal to y. When we do that, we're going to do the thing we did before, which is just the 2 negative, so the 2's up there, then 2 times 1, that's the negative part, that's what I mean. We're figuring out where our line of symmetry is, so it's going to be on 1. So this is going to be our line of symmetry right here when x is equal to 1. That makes sense. Now, if I want to plug it in, I can see where my point is going to be. My point is going to be way down at the bottom here because it's going to be 1 squared. I got my line of symmetry, but if I want to figure out where my trough is of my actual equation of my parabola, then I need to figure this out. 2 times 1. I'm just plugging in the x values here. So this is actually going to be negative 16. So it's going to be way down here. If this is 2, 4, 6, 8, 10, 12, 14, 16. If I say that's 16 right there, so 2, 4, 6, 8, 10, 12, 14, 16. So right there, that's going to be my trough. I'm pointing in the right direction. I'm pointing up, so I will get there to be it will cross the axis because the a value is positive. So now I'm just going to factor this where it's going to be. If I can actually do this easily. So I'm just going to change that when it's equal to 0. So it's going to be x minus 5 and x plus 3. So my two solutions are going to be when x is going to be equal to negative 3, and also x is going to be equal to positive 5. And that makes sense because it shifted over. A little bit. So x is, and that's when y is equal to 0. So 1, 2, 3, 4, 5. So right there, and 1, 2, 3, 4, 5. So it's going to be right there. So that's how it's going to look. That makes sense because it's a nice, if I could actually draw, a nice symmetrical one. So very important to understand, a quadratic equation has two solutions if it has two x-intercepts. And a quadratic equation has one solution if the graph of its related function only has one x-intercept. And so remember, back here, we had the one solution. Here, we have the no solutions. And here we have two solutions. So those are examples of each of those. And here, we're just going to go ahead and factor this to figure it out. It would be y is equal to x squared minus 4. When we plug in, we can figure out what this is. This is actually going to be nice and neat. It's going to be shifted down to 1, 2, 3, 4. That's going to be my point. That's going to be the y. Remember, this is the c value, so that's going to be where it crosses the y-axis when x is equal to 0. And now it's just going to be up on either side. So if I want to do this, it's going to be x plus 2, x minus 2. That's going to be equal to 0. So the roots are there, so it's going to be there and there. That's going to be nice and symmetrical. And there we go.